Okay, here we want to look at what's called a geometric series. Now, a geometric series is the most common type of series that we usually see. Now, these are the first things we want to know about a geometric series. If the ratio, or better yet, the absolute value of the ratio is greater than or equal to 1, the series diverges. Say it again. If the ratio is greater than or equal to 1, the series diverges. Now, if the ratio is less than 1, the series converges, but it converges to a sum of A over 1 minus R, where A is the first term of the series and R is the common ratio. So let's look at example 1. Here we have the series, we're going from 1 to infinity, of 3/2 to the n power. Now, for this first one, I'm just going to put up my first few terms in just so we can see. So if we were to list these terms, and as you get more and more experience, you will be able to look at a lot of them and tell what's your common ratio, but I want to actually put these in. 3/2 to the first power would be 3/2. This is a series, so we definitely have summation. 3/2 to the second power, 3 to the second power over 2 to the second power, would be 9 over 4. Let's look to the third power. 3 to the third power over 2 to the third power. 3 to the third power is 27. And 2 to the third power would be 8. So we would just keep going right here and keep plugging numbers in. This is an infinite series. But we have to look at this. To go from 3/2 to 9/4 to 27/8, what's our common ratio? Our common ratio would be what? 3/2. Now, one thing that we can see, 3/2 is greater than 1. So the series diverges. The end. The common ratio, the ratio between each term, is greater than 1, so it diverges. Now, I want us to look at this one. Now, we're going to look at something that looks very similar. It looks very similar, but just a slight change to it. And this is how series can be tricky. Let me draw something in here to separate. Okay. Now we have 3 over 2 to the n. Now, if we look closely, we can see the problem above, the exponent was going to go with the 3 and the 2. Now, the exponent is only going with the 2. So be careful right here. So let's look at our first couple of terms just to see what's going on. So 3 over 2 to the first power would be 3 over 2. 3 over 2 to the second power would be 3 over 4. 3 over 2 to the third power would be 3 over 8. And we would just keep going on and on and on and on right there. Now, let's look at this. In the numerator, we're going from 3 to 3 to 3 to 3. That would never change. So we basically have to multiply by 1. In the denominator, we're going from 2 to 4 to 8. And if you put another number, that would be 16 and then 32. So our common ratio, From the numerator, we're multiplying by 1, and in the denominator, we're multiplying by 2. But in this case, the ratio is 1/2. But remember, 1/2 is less than 1. So this series converges. But we need to find the sum. So it converges to A over 1 minus R. And I'm going to come back up here. Remember, we can look at number 2. A is the first term of the series, and R is the common ratio. So it converges to 3 over 2 over 1 minus the common ratio, which is 1/2, which is 3 over 2 over 1/2. And we remember, whenever we divide by a fraction, we multiply by the reciprocal. That's just an old algebra rule. So this converges to 3. This series converges to 3. What's that saying is, if we decided to add up all the terms of the series, it would converge to a sum of 3. So this is just a quick example for testing the convergence and divergence of a geometric series.